You've heard the buzz, right? Generative AI, I mean, it's everywhere. Transforming industries, creating content, accelerating discovery, it's huge.
It really is. Hard to miss.
But beyond those headlines, the sheer awe of it all, how are organizations actually implementing this stuff, this powerful technology,
Right.
to gain a real, lasting competitive edge? What does it truly take to move from just playing around with it, the experimentation phase, to real enterprise-scale success?
And that's precisely what we're diving into today.
Hmm.
Our mission really is to unpack the most crucial insights from the GenAI enterprise, a strategic blueprint for implementation across industries by Rick Spare.
Okay, Rick Spare, good source.
Yeah, and this isn't just another, high-level chat about AI's potential.
Hmm.
Spare's blueprint gives you an actionable guide. It details what it takes to actually do this rather than just, talk about it.
Exactly. We want to get beyond the hype, give you clear understanding of the actionable steps. We'll explore 3 foundational pillars of successful generative AI adoption.
Right, the core pillars.
First, the human capital, because, maybe surprisingly, humans are still the secret sauce here.
Definitely.
Second, the technology stack. The stuff that actually powers these incredible systems.
And that's a bold.
And third, the critical governance and implementation frameworks. These ensure everything runs ethically, efficiently, all the important guardrails.
Uh-huh.
And we're not stopping there. We'll even look at how these pillars apply differently across specific industries, because let's face it, a one-size-fits-all approach just doesn't cut it here.
No, context is everything.
Mhm.
So whether you're prepping for maybe a high-stakes meeting where Gen AI is definitely on the agenda,
Yeah, could be.
or you're just trying to catch up on this field because, wow, it evolves fast.
So fast.
Or maybe you're simply, like us, genuinely curious about how this technology is transforming the business world. Well, this deep dive is your shortcut to being genuinely well-informed.
You'll walk away with a clear understanding, we think, of what it truly takes to transform generative AI from just a promising technology into a core driver of productivity, innovation, and a durable competitive advantage.
Let's go.
Okay, let's unpack this. So we're kicking things off with what might be the most surprising and frankly maybe reassuring aspect of enterprise generative AI. It's fundamentally a human capital challenge. When Gen AI first burst onto the scene, remember all that talk? Automation, robots taking jobs.
Oh, yeah, that was the dominant narrative, wasn't it?
Totally. But that conversation is, it's quickly evolving.
That initial discourse was, heavily centered on automation and this fear of widespread job replacement. But Spare's blueprint really emphasizes a pivotal shift. The conversation is giving way to a far more nuanced understanding of AI as a tool for augmentation. And this is crucial because the competitive edge that was once promised by simply having access to powerful Gen AI models, well, that's rapidly eroding. These tools are becoming universally available.
Right, everyone can get their hands on them now.
So the differentiation isn't really in the technology itself anymore, but in how organizations leverage it.
Okay, and here's where it gets really interesting, I think. The report makes a compelling case that the true and sustainable differentiator in this Gen AI era is human capital. I mean, think about it. Gen AI is fantastic at generating content, writing code, processing data. Amazing stuff.
Unbelievably fast.
But it fundamentally lacks. It lacks contextual understanding, nuanced judgment, that human insight required for high-stakes decisions, and crucially, genuine innovation.
That spark.
Exactly. That unique human skill, institutional knowledge, lived experience, that becomes the ultimate competitive advantage.
Precisely. Successful enterprises aren't just buying the best models. They're architecting their workforce strategy to blend technology and human talent, to maximize the value of both.
So it's a blend.
And this isn't just a minor tweak, It's a fundamental reorientation of workforce planning. Historically, many organizations focused on capacity, asking, how many people do we need?
Right, the head count.
Now, leaders must, and indeed can, begin with capability, asking who possesses the cognitive skills to solve this problem. Gen AI then becomes a force multiplier, amplifying those human abilities.
So it's all about enhancing those core human competencies that AI just can't replicate. Things like creativity, critical thinking, building relationships, and what the report calls nonlinear problem solving.
Yeah, that ability to connect disparate dots.
These are the areas where human intelligence remains, well, unparalleled, and this strategic reorientation demands a much deeper integration between human resources and information technology.
That's a key point Spare makes.
Yeah, Spare suggests that effective AI adoption is as much an HR initiative as it is a technological one, which is maybe counterintuitive at first.
It can seem that way, but makes total sense when you dig in. The most forward-thinking organizations are not viewing GenAI as just a tool to be used by humans,
Right.
but as a partner to collaborate with humans.
Mm.
This leads to what Spare calls co-intelligence.
Co-intelligence, I like that.
Yeah, it's where GenAI handles the repeatable tasks, freeing human workers to focus on more complex cognitive work.
Yeah.
It's about humans with machines, not humans or machines, fundamentally redefining workflows as this holistic, collaborative process.
Wow.
And this new model redefines roles, processes, even cultural norms, firmly placing HR right at the center of this technological transformation. It's a big shift.
Okay, understood. So if we're building this co-intelligence workforce, what does the dream team actually look like? Because implementing GenAI at enterprise scale, well, it's clearly not a one-person or even one-department job, is it?
Not even close.
The blueprint emphasizes a critical first step, assembling a dedicated cross-functional team, one that bridges business strategy, tech execution, and importantly, ethical governance. What's the core insight here about team building?
Well, the core insight is that effective GenAI teams aren't just technical wizards. They're a blend of diverse expertise, and that includes entirely new categories of roles that are emerging and becoming mission critical. Yeah, the report breaks these down into 3 key categories. First, you've got the technical roles, the builders. They form the engineering core.
Okay, the hands-on folks.
Exactly. This includes the AI architect, who designs the end-to-end AI system, making sure it's scalable, secure, the whole shebang.
Got it.
Then the data engineer, they're the backbone really, building and maintaining those robust data pipelines for high-quality data collection, transformation, storage, all the stuff needed for training and grounding Gen AI models.
Crucial. Without good data.
You got nothing, basically. Then the machine learning, ML engineer, they bridge data science and production, deploying, scaling, and optimizing the models for reliability.
Okay.
And finally, the AI developer focus more on writing the code and implementing the algorithms for specific AI solutions.
Right, the builders. Then you mentioned other categories.
Yeah, second category, strategic and product roles, the translators. This group makes sure all that technical work actually delivers business value.
Ah, the connection to the business, important.
Super important. You've got the head of AI, or maybe head of HR innovation. That's the executive sponsor, providing the vision, resources, C-suite alignment.
The champion.
Exactly. Then the AI product manager. They operate like the CEO of the AI product, defining the vision, doing market research, making sure solutions meet user needs and deliver actual business value.
Okay.
And then there's a particularly fascinating new role, the prompt engineer.
Ah, yes, I've heard a lot about this one. What's the deal there?
It's critical. Really, this is a new emerging craft specializing in designing and refining the natural language inputs, the prompts that guide these large language models, or LLMs.
So like telling the AI what to do, but really well.
Exactly. It requires this unique fusion of linguistic precision, deep domain expertise, and an intuitive grasp of how the model behaves to get accurate, relevant responses. It's harder than it sounds.
I bet.
And tying it all together, the data and AI translator, they act as that crucial communication bridge between the technical teams and the business teams. Super vital role.
Okay. Builders, translators, and the third group.
The governance and ethics roles, the guardians. These are the folks establishing the guardrails, making sure you're doing things right.
The conscience of the operation.
Sort of, yeah. You've got the AI ethicist or AI ethics officer. They develop and enforce the ethical standards, proactively addressing bias, fairness, transparency, societal impact.
Okay.
And then operationalizing those principles, you have the AI governance manager or AI risk and governance specialist. They set up the policies, the compliance frameworks, the risk assessment protocols. They work really closely with legal and IT security.
Got it. That's quite a team structure.
It is. And what's also fascinating is the rise of this sort of hybrid role, the AI engineer.
Okay, what's that?
Well, traditionally, there were pretty sharp distinctions between, say, PhD-level data scientists doing fundamental research and ML engineers focused on production.
Right.
But with these powerful, pre-trained foundation models accessible via APIs, well, those lines are blurring.
Ah, because you don't always need to build from scratch.
Exactly. For many applications, the main challenge isn't building a model from the ground up, but integrating these existing models, orchestrating the API calls, implementing techniques like retrieval augmented generation RE, and doing fine-tuning.
So it's less about deep theoretical ML research and more about practical application and integration, getting things working in the real world?
Precisely. And this is a significant strategic advantage for organizations. It allows them to build and deploy GenAI applications more rapidly by upskilling their existing engineering talent.
Ah, retraining current staff.
Yeah, rather than competing for that very limited, very expensive pool of top-tier ML researchers, it makes GenAI adoption more feasible for more companies.
Oh, okay, so that's the ideal team structure, the different roles. But what are the actual skills these individuals need? The blueprint stresses, you said, this dual-sided skill set, balancing deep technical proficiency with uniquely human capabilities. It's not one or the other, it's both working together.
That's a critical insight, yeah. On the technical side, the hard skills, you absolutely need unwavering proficiency in programming languages. Python is still king here.
Python, okay.
This has to be complemented by a strong command of data structures. Things like Python dictionaries, manipulation libraries, pandas, NumPy are essential, and database querying languages like SQL. All absolutely essential for preparing and managing the vast data sets that power AI.
Makes sense. Data wrangling is still a huge part of it.
Oh, massive.
Yeah.
And it's not just about coding. You need a robust conceptual understanding of deep learning and neural network architectures like transformers, for instance.
Understand how it works under the hood.
You really do.
Yeah.
Not just how to call the API,
Yeah.
and hands-on experience with the dominant frameworks like TensorFlow, PyTorch, Keras. That's essential for implementation.
Okay.
And given that most enterprise GenAI apps leverage pre-trained models, the ability to effectively work with APIs from providers like OpenAI, Google, Anthropic, that's a core skill now.
Great, interacting with those big models.
And this is inseparable from proficiency in major cloud platforms, AWS, Azure, Google Cloud, which provides the necessary infrastructure for training, deployment, scaling, the whole life cycle.
Got it. So those are the hard technical skills. What about the other side, the power skills?
Right, the human-centric skill sets. These are the durable, uniquely human abilities that truly differentiate value-creating AI implementations from just, technical exercises. First up is enhanced critical thinking and problem solving.
Crucial, I imagine.
Absolutely paramount.
Hmm.
Gene AI models can hallucinate, right? They produce plausible sounding but totally incorrect information.
Yeah, confidently wrong.
Exactly. So the ability to critically evaluate AI outputs, identify logical inconsistencies, apply sound judgment, it's vital. It also involves deconstructing complex business problems into logical sub-questions that you can actually ask the AI system.
This one resonates so much. It's not just about accepting what the AI spits out. It's about discerning its validity, questioning it.
You have to. Then there's creativity and nonlinear thinking.
Yeah,
These are quintessential human traits, right?
for sure.
In Gen AI, creativity isn't just about artistic output, like making images. It's about asking novel questions, connecting disparate ideas, envisioning innovative applications for the technology, that classic think outside the box capability.
Using the AI as a springboard for new ideas.
Exactly. And perhaps the most important meta skill, given the breakneck pace of change, is learning agility and adaptability.
Ah, keeping up.
Seriously. The Gen AI landscape is evolving so fast. Tools, models, best practices, they can become outdated in months, literally. So the capacity for continuous rapid learning and the flexibility to adapt to new workflows are arguably the most important skills for the entire workforce.
I can certainly see that constant learning curve. What else?
Next, contextual intelligence and business acumen. Implementing technology without a deep understanding of the business context is just, well, it's a wasted investment.
Right, tech for tech's sake doesn't work.
Nope. This is the ability to grasp an organization's strategic objectives, its operational realities, stakeholder needs, and to pinpoint where Gen AI delivers the most significant value, connecting the tech to the business goals.
Okay. And finally?
Finally, ethical judgment and digital literacy, a foundational understanding of the ethical dimensions of AI, including potential biases lurking in data, privacy implications, the need for fairness. This is no longer a niche concern for just the compliance department.
It's for everyone now.
It's a core competency for everyone involved in building or using AI systems, period.
And this is where it all connects back to the return on investment, the ROI.
Absolutely. The report makes a crucial point here. The ROI from those technical skills is directly contingent on the strength of an organization's power skills.
Say more about that.
Well, you could hire the most brilliant ML engineers in the world, right?
Sure.
Wizards. But if they lack the business acumen, understand the problem they're solving,
Yep.
or the contextual intelligence to guide the model appropriately, or the critical thinking to question a flawed AI-generated solution, then the project is probably destined for failure, or at least underperformance.
That's a profound insight. It suggests that maybe domain experts, like, say, a product manager or a salesperson who doubly understands customer needs, they might actually make better prompt engineers than pure technologists sometimes.
Often, yes.
Yeah.
Simply due to their contextual knowledge. They know the right questions to ask, the nuances of the domain.
Interesting.
So investing in upskilling the workforce in critical thinking, creativity, ethical judgment, this isn't some soft HR initiative. It is a direct and necessary investment in maximizing the financial and strategic returns of the entire technology stack.
It truly is the ultimate competitive advantage, then, the human element.
At the end of the day, yes.
Okay, so we've talked about the people, their skills, critical stuff. But how do you actually structure these teams within an organization? The blueprint notes you mentioned, there's no single universally correct way. It really depends on the company's maturity, scale, culture, goals.
That's right. Context matters hugely here. The report outlines 3 main organizational models that companies tend to adopt. First, there is the centralized model. This is often referred to as a center of excellence, or COE.
COE, right, heard that term.
In this setup, a single central team houses the organization's deep technical AI expertise. They're responsible for foundational research, developing core AI platforms and tools, setting standards, and tackling those large, complex R&D projects.
So good for building initial capabilities, getting
Yeah.
things started.
Exactly, and for ensuring consistency across the organization.
Makes sense? Then what's the alternative?
Well, there's the decentralized or embedded model. This approach integrates AI specialists directly into individual business units or product teams like marketing, supply chain, finance.
So the AI folks sit right with the business folks.
Pretty much. This structure fosters deep domain knowledge because they're right there, living the problems. It ensures AI solutions are tightly coupled with real-world user needs, and it promotes agility and ownership at the business unit level.
I can see the benefits there too, faster response to specific needs.
Definitely. And then for most large organizations, the report suggests a hybrid model, or hub and spoke, often offers the best of both worlds.
Hub and spoke. Okay, how does that work?
You have a central COE that's the hub, handling governance, overall strategy, shared infrastructure, and providing deep expertise on demand.
So the core standards and deep knowledge are central.
Right. And this is combined with embedded AI experts or smaller AI teams, the spokes, out in the business units.
Oh.
The spokes are responsible for driving the frontline implementation, identifying new use cases specific to their area. This model tries to balance that centralized control on standards with business unit agility on domain-specific innovation.
I appreciate that. It sounds like a way to get the benefits of both centralized consistency and decentralized speed without being too rigid.
It's often the most practical approach for larger, complex organizations.
And regardless of the chosen structure, centralized, decentralized, hybrid, pie part, the report emphasizes a phased approach to team growth, right? You don't just flip a switch and have a massive AI department overnight.
Please don't try that. A much more prudent strategy is to start small, prove the value, and then scale based on tangible success.
Okay.
Yeah, this often begins with what they call a 0-to-1 team. This initial team is lean, cross-functional, dedicated to a specific high-value proof of concept, or PC.
Like a pilot project team.
Exactly.
Yeah.
Typically just a data scientist, an ML engineer, and maybe a product manager. Once this small team demonstrates clear ROI, clear value.
Then you get more buy-in.
Exactly. Then the organization can justify further investment and start to scale, adding more specialized roles like data engineers, MLOps specialists, dedicated governance managers as the project complexity grows.
That's a very practical, iterative approach. Build momentum.
It de-risks the investment significantly.
And the blueprint goes into how these roles actually interdepend, highlighting the collaboration needed. It's not just silos, is it?
Oh, absolutely not. For example, an AI architect needs deep knowledge of cloud architecture and MLOps principles. But they work incredibly closely with data engineers to ensure data requirements are met upfront, and with ML engineers to make sure the models can actually be operationalized effectively. It's all about that constant collaboration.
Right. And you mentioned the prompt engineer earlier.
Yeah. Take the prompt engineer. They need excellent written communication, creativity, deep domain expertise. But they aren't working in a vacuum. They collaborate closely with AI developers to fine-tune the model outputs for specific applications, iterating constantly. And then you have the AI governance manager. They're absolutely critical for regulatory compliance. They have to translate those high-level ethical principles from the AI ethicist into auditable, enforceable operational controls. They're the linchpin connecting the ethical guidelines to the practical implementation on the ground.
It really highlights how deeply interconnected these roles are. It's a complex ecosystem of talent and skills, all needing to work together smoothly.
It really is. Building the team and the structure is a major piece of the puzzle.
Okay, so we've built our dream team, equipped them with the right skills, decided on an organizational model. We've covered the human side. Now let's shift our focus to the actual tools, the technology.
Yeah, tech stack, yeah.
Because while human capital is the strategic differentiator, you still need a robust and well-architected technology stack. That's the essential foundation, right? Making the right choices here seems critical for scalability, performance, long-term success.
Absolutely.
Yeah.
You can have the best team in the world, but if the tech isn't right, you'll struggle. At the heart of every generative AI application is a foundation model.
Okay, the core engine.
Exactly. A large, versatile, pre-trained model that can be adapted to a wide range of tasks through prompting or fine-tuning. The selection of which model and which platform to use it on is a primary strategic decision. It really shapes an organization's entire AI program.
And the market here is pretty much dominated by a few major players right now, isn't it?
It largely is, yeah. You have OpenAI Microsoft. OpenAI's leading models, like the GPT series, are deeply integrated into Microsoft's Azure cloud.
Right, the Azure OpenAI service.
Exactly.
Yeah.
That gives enterprises state-of-the-art capabilities within a secure, enterprise-grade environment. Plus, you have things like Microsoft 365 Copilot, really driving rapid adoption by embedding this technology directly into everyday workplace applications people already use.
Make it very accessible.
Then there's Google. They were pioneers in the underlying transformer architecture that powers most of these models.
Right, they invented it.
They offer powerful models like Gemini and PolM, accessible through their Vertex AI platform on Google Cloud. Vertex AI is designed as a comprehensive, unified environment for the entire AI lifecycle, building, deploying, managing.
Okay, so another major integrated platform, and Amazon, AWS.
Yeah, Amazon AWS takes a slightly different approach, more open, ecosystem-centric, you could say, through Amazon Bedrock.
Bedrock, right.
They offer their own proprietary models, like Amazon Titan, but also a curated selection of industry-leading third-party models from partners. Think Anthropic's Claude, Cohere.
So more choice of models on one platform.
Exactly. This provides customers with significant flexibility and choice without being locked into a single model provider. It's a smart strategy for their diverse customer base.
Interesting. And beyond these big proprietary players, there's the open source world, too.
Oh, absolutely. There's a vibrant open source ecosystem. Models like Meta's Llama series, which you can access through platforms like Hugging Face, offer organizations greater flexibility, transparency, and control.
What are the trade-offs there?
Well, they eliminate licensing fees and vendor lock-in, which is attractive. But they do require significantly more in-house expertise to deploy, manage, maintain, and often fine-tune effectively. So it's a clear trade-off. Control versus convenience and potentially higher internal costs.
That's a big decision point for many organizations, I imagine. Control versus ease of use.
Definitely.
And the choice of a cloud platform, AWS SageMaker, Google Vertex AI, Azure AI, it often goes beyond just picking a model, doesn't it? We're talking about end-to-end machine learning operations or MLOps platforms.
Indeed. These platforms provide the full suite of tools needed. Data preparation, model training, fine-tuning deployment, monitoring, governance, the whole life cycle.
So the platform choice is about the whole ecosystem.
Yeah. The decision typically aligns with an organization's existing cloud infrastructure, specific model requirements, data residency needs, which are huge, and the desired level of integration with other enterprise systems. It's a holistic choice, not just selecting a single tool in isolation.
Okay, so once you've got your foundational models and cloud platforms sorted, how do you actually build and deploy these applications? Because, like you said, simply calling a model's API isn't really enough for sophisticated enterprise use cases.
It certainly isn't. You need more structure. This is where application development frameworks come into play. Two open-source frameworks have really become the de facto standards for building applications powered by LLMs, LangChain, and Llama Index.
LangChain and Llama Index. Okay. What do?
They provide these modular tools that simplify common tasks. Things like managing prompts effectively, connecting LLMs to various data sources, APIs, databases, documents, and creating multi-step chains or agents that can perform more complex reasoning or actions.
So they help orchestrate more complex interactions with the LLM.
Exactly. They're crucial for building complex interactive applications that go way beyond simple chatbots. They handle a lot of the plumbing.
That sounds like they simplify a lot of the heavy lifting for developers. Good to know. And when we talk about deployment, getting these things into production, we're talking about ML ops for generative AI.
Right.
This discipline combines machine learning, DevOps, data engineering to deploy and maintain ML models reliably. But Gen AI introduces new challenges here, doesn't it, compared to traditional ML?
It absolutely does. While the big MLOps principles still apply automation, monitoring, reproducibility, GenAI brings unique complexities to the table.
Such as?
Well, for instance, just managing the extremely large model checkpoints in their versions. These models are huge.
Right, gigabytes or more.
Then there's evaluating non-deterministic outputs. With traditional ML, you often have a clear right or wrong answer. With GenAI, there's often no single correct answer, so evaluating quality is trickier.
How do you measure good text or a good image consistently?
Exactly. And then you need continuous monitoring specifically for things like prompt response quality, semantic drift, where the model's understanding changes over time, toxicity, and bias in the model outputs. These are critical for GenAI.
Those are definitely new considerations. So what kind of specialized tools are emerging for this Gen AI ML ops lifecycle?
There's a whole ecosystem popping up. For experiment tracking, you have tools like MLflow, Weights and Biases, WMB, Comet ML. They help log, compare, and manage the potentially thousands of experiments involved in prompt engineering and fine-tuning.
Keeping track of what works.
Essential. For workflow orchestration, platforms like Kubeflow, Prefect, or Cadro help automate and manage those complex data and model pipelines.
Okay.
For model deployment and serving, solutions like BentML, Hugging Face Inference Endpoints, or Ray are designed to efficiently package, serve, and scale these often very large models for real-time or batch inference.
Getting them out there reliably.
And then crucially, for monitoring and observability, a new class of tools has emerged specifically for LLMs. Think, Evidently AI, Fiddler AI, Arise AI. These track metrics related to output quality, data drift, bias, and those infamous hallucinations, unique failure modes for generative models.
Right, you need tools that understand those specific Gen AI risks.
You really do. It's a specialized area.
This whole ML ops pipeline, the blueprint puts it nicely, saying it sounds like a factory.
Yeah, it's the production line for AI.
And it highlights this really symbiotic relationship between ML ops and governance. The ML ops pipeline is the factory deploying the models, but it's kind of directionless without the quality control of AI governance, right?
Precisely. Think about it.
Yeah.
An ethical committee might set a specific bias threshold for, say, a loan approval model.
Okay.
The MLOps monitoring tool is then configured to continuously track that bias metric.
Yeah.
If the model's performance drifts beyond that predefined ethical boundary,
It gets flagged.
it gets flagged, or maybe even automatically rolled back to a previous version. The report makes it crystal clear. Investing heavily in MLOps without tightly integrated governance is like building a high-speed assembly line with no quality inspectors. You're just producing flawed outputs faster.
That's a really impactful analogy. Build fast, break things, but maybe not when things are fairness or compliance.
Exactly. You need both speed and control.
And speaking of control in data, the blueprint really emphasizes that the ultimate data backbone for enterprise Gen AI, particularly for grounding it in reality, is the vector database. Can you explain why that's so critical?
Yeah, this goes back to a fundamental limitation of standard LLMs we touched on earlier. They're stateless, meaning their knowledge is basically frozen at the time of their last training run. They have no inherent access to an organization's private, real-time, or domain-specific data.
Right. They don't know about my company's latest products or internal policies.
Exactly. This leads to them being unable to answer questions about recent events or proprietary information. And crucially, it makes them prone to hallucination, generating those confident-sounding but factually incorrect answers.
The dreaded hallucination problem again. So, vector databases are the fix. Or part of it.
They are a key part of the solution, especially when combined with an architectural pattern called Retrieval Augmented Generation, or RAG.
RAG. Okay, vector databases and RAG, how do they work together?
So a vector database stores data differently. not as text or rows in a table, but as high-dimensional numerical representations called vector embeddings.
Vector embeddings, like coordinates in a high-dimensional space?
Kind of, yeah. These embeddings capture the semantic meaning and context of the original data. This enables incredibly powerful semantic search based on conceptual similarity, not just finding exact keyword matches.
So searching for meaning, not just words.
Exactly.
Okay, so how does that work in practice with RAG? Walk me through it.
Sure. The workflow is quite clever, actually. First, an organization takes its proprietary documents. Think technical manuals, financial reports, HR policies, knowledge base
A
articles.
lot of internal stuff.
Right. They process this text using an embedding model, which converts chunks of text into vectors, and then stores these vectors in a vector database.
Okay, so the internal knowledge is now vectorized.
Step 1. Then, when a user submits a query, say, what's our travel reimbursement policy for international flights? The system first converts that query itself into a vector embedding using the same model.
Okay, query becomes a vector.
Step 2. It then uses this query vector to search the vector database and retrieve the most semantically similar and relevant chunks of text from the original source documents. It finds the parts of the HR manual that talk about international travel policy.
Based on meaning, not just keywords.
Correct. Finally, this retrieved factual context is injected directly into the prompt that's sent to the LLM. The prompt essentially instructs the LLM, answer the user's question, but use only the provided information from these documents.
That's brilliant. So it effectively gives the LLM an external memory filled with the company's own trusted information.
Exactly. It grounds the LLM's response in verified, up-to-date, domain-specific information. And this dramatically reduces those hallucinations because the model isn't just relying on its general, potentially outdated training data.
It's forced to use the facts you just gave it.
Precisely.
And the market for these vector databases must be exploding then.
It really is. You have purpose-built vector databases like Pinecone, Weaviate, Milvus, Qdrant. These are specialized for high-performance vector search at scale.
Okay.
But also, vector search capabilities are being added to existing databases. Things like Amazon OpenSearch Service, Amazon Aurora PostgreSQL using the PG vector extension, Elasticsearch. They now offer vector search. So organizations can often leverage their existing infrastructure, which is a big plus.
That makes adoption easier. This whole R approach sounds like a genuine game changer for enterprise AI.
It really is. The report states that adopting R transforms a company's vast, often unstructured internal data from being just a passive liability, sitting there,
Right, just files on a server.
into a dynamic, queryable asset. This proprietary data becomes a key source of sustainable competitive advantage
How so?
because it allows a company to create highly customized, accurate, and domain-specific GenAI applications that competitors simply can't replicate easily, like that internal chatbot for field technicians drawing on thousands of specific service manuals no one else has.
Because the competitor doesn't have your internal data.
Exactly. The investment in a vector database and implementing ARG isn't just an IT infrastructure cost. It's a strategic investment in activating and monetizing potentially decades of accumulated institutional knowledge. That's where you find true defensible competitive edge.
Okay, fascinating stuff on the tech side, especially RA. So we've covered the people, the human capital, and the tech stack. But as the blueprint reminds us, a powerful technology stack and a talented team, well, they're necessary, but they're not sufficient for enterprise-wide GenAI success.
True. You need more.
Without proper frameworks to guide the implementation, even the most promising initiatives can falter or, worse, cause real problems. This is where governance, risk management, and project management come into the picture.
Absolutely. The how of managing a GenAI program is just as critical as the what or the who. First, let's talk about establishing robust AI governance.
Okay, governance. What does that really mean in this context?
Well, it's a comprehensive oversight framework. Think principles, standards, policies, practices, all designed to direct the responsible, reliable, and ethical use of artificial intelligence within an organization.
So the rules of the road for AI.
Pretty much. Its primary purpose is twofold. Maximize the value you get from AI while minimizing the potential risks. And those risks are real. Biased outputs, regulatory non-compliance, security threats, privacy breaches.
Right, lots that can go wrong. And you mentioned earlier it builds on existing data governance.
Exactly. AI governance extends traditional data governance principles to the entire AI system. The models, the algorithms, the training processes, even the content generated by the AI. A mature data governance program is actually a prerequisite.
Why is that?
Because the reliability and fairness of any AI model are directly dependent on the quality, completeness, and representativeness of the data used to train it. Garbage in, garbage out.
Yeah.
Still very much applies.
Makes perfect sense. Data quality underpins everything. So what are the core principles guiding this AI governance?
The blueprint highlights 4 key ones. First, transparency. Stakeholders, users, regulators, internal teams need to understand how an AI system works and makes decisions. This means aiming for explainable models where possible, documenting data sources clearly, and avoiding opaque black boxes when the stakes are high. It's the foundation of trust.
Okay, transparency. What's next?
Second, fairness. AI systems must be designed and actively tested to avoid unfair bias against individuals or groups. This requires proactive effort, careful data curation, bias detection tools, mitigation techniques.
So actively fighting bias, not just hoping it isn't there.
Right. Third, accountability. There must be clear human responsibility and oversight for AI system outcomes. You need audit trails, defined roles for human review, and mechanisms for redress when mistakes inevitably happen. Someone needs to be accountable.
Humans still in charge.
Ultimately, yes.
Mm-hmm.
And fourth, privacy and security. Stringent standards are needed to protect sensitive data used in AI systems and also to secure the models themselves from attacks or unauthorized access. This is crucial for both compliance and maintaining user trust.
Okay, transparency, fairness, accountability, privacy, security, good principles. But how do you actually operationalize these? They can't just be words on a page, right?
Absolutely not. It requires concrete action. This includes things like establishing a cross-functional AI ethics committee or review board,
Okay, a dedicated group.
developing a formal AI code of conduct for employees, conducting regular audits and risk assessments specifically for AI systems, and implementing comprehensive training programs on responsible AI for all relevant staff, from developers to users.
And leadership buy-in.
Crucially, commitment must be driven from the top. The CEO and senior leadership have to set the tone and provide the resources. It has to be part of the company culture.
Given all these potential risks, bias, security, privacy, it's not surprising that various governments and industry bodies have developed AI risk management frameworks.
Yeah, there's been a lot of activity here.
These provide systematic approaches to identify, assess, and mitigate those AI risks.
Yes, and it's important to understand these frameworks aren't necessarily mutually exclusive. In fact, they're often most effective when used complementarily, layering them together.
Okay, so what are some of the key ones people should know about?
Well, let's look at a few prominent ones. The NIST AI Risk Management Framework, AIRMF, from the U.S. National Institute of Standards and Technology.
NIST, okay.
It's voluntary, designed to be flexible, very practical. It's organized around 4 core functions: govern, map, measure, and manage. It provides a structured process that organizations can adapt to their specific context. Think of it as a great internal playbook for managing AI risk day to day.
Practical, adaptable, good. Then across the pond, there's the EU AI Act. That one's getting a lot of attention.
Huge attention. And unlike NIST, it's a landmark piece of legally binding legislation.
Right, it has teeth.
It uses a risk-based approach, categorizing AI systems. Unacceptable, which are banned outright; high risk, subject to strict requirements; limited risk, requiring transparency; and minimal risk, largely unregulated.
And the high-risk category is the important one for businesses.
Very much so. It imposes significant requirements on high-risk systems.
Yeah.
Things like data quality standards, human oversight, accuracy, robustness, cybersecurity. And there are substantial fines for non-compliance. This is becoming the de facto legal benchmark, certainly for operating in Europe, and likely influencing regulations elsewhere too.
Okay, so NIST for internal process, EU AI Act for legal compliance in Europe. What else?
Well, Google, drawing from its own extensive internal experience, published its Secure AI Framework, SAIF.
SAF.
This is a practical guide focused specifically on the security aspects of building and deploying AI systems. It provides concrete best practices for securing the entire AI development lifecycle, protecting training data, hardening models against attacks, securing deployment infrastructure. It's a very useful set of technical controls for security teams.
Focused on security. Got it. And more globally.
The OECD AI principles have been highly influential.
OECD, right.
These are global, human-centric ethical standards. They focus on things like inclusive growth, human-centered values, transparency, robustness and security, and accountability. They provide a high-level ethical compass, a set of values for responsible AI development globally that many frameworks build upon.
So for a multinational corporation operating globally, it's not about picking just one of these frameworks, is it? It's more like using them together in a layered approach.
Precisely. That's the most effective strategy. A multinational could, for example, use the NIST AI RMF as its internal playbook for managing risk daily.
Okay.
Use the EU AI Act as its legal and compliance benchmark, ensuring market access in Europe.
Uh-huh.
Use Google's SAIF to provide specific technical guidance for hardening the security of its development pipeline.
Right.
And use the OECD principles for high-level ethical alignment discussions at the board level and in public communications. This creates a far more comprehensive and resilient governance posture than any single framework could provide on its own.
So it's about being operationally robust, legally compliant, technically secure, and ethically aligned, covering all the bases.
That's the goal. It's complex but necessary.
Okay, that makes sense for managing risk. But how do we actually manage the projects themselves, getting this stuff built and deployed? Traditional project management methods, like the waterfall approach, they seem fundamentally ill-suited for AI projects. Why is that?
You're spot on. Waterfall relies on predictable environments, stable requirements, known inputs and outputs. AI projects are rarely like that.
How so?
They're inherently experimental. They often start with fuzzy objectives. Can we use AI to improve X? They're heavily dependent on data exploration, which can yield surprises. And there's often significant R&D involved just to determine if something is even feasible. Trying to plan that all out up front in detail is usually futile.
So waterfall is out. What's the alternative? Agile methodologies like Scrum or Kanban?
Absolutely. Agile is a much better fit. Its core principles, flexibility, iterative development, cross-functional collaboration, continuous feedback align perfectly with the exploratory, uncertain, and data-driven nature of AI development.
But you can't just apply standard agile practices straight out of the box, can you? AI seems to require specific adaptations.
That's right. The blueprint highlights several key AI-specific agile adaptations. First, embrace data-driven decision-making. Prioritization shouldn't just be based on a predefined feature list. It needs to be guided by objective evidence coming from data exploration and actual model performance metrics. Let the data guide the way.
Okay, data drives priorities. What else?
Second, foster deep cross-functional collaboration. AI projects aren't siloed activities where one team hands off to the next. They require tight, continuous collaboration among data scientists, ML engineers, developers, domain experts, product managers, right from the very beginning and all the way through.
Constant communication.
Essential. Then there's the idea of building a minimum viable AI, MVAI.
MVAI, like a minimum viable product, MVP, but for AI.
Exactly. Instead of trying to build the perfect, all-encompassing AI solution from the start, teams focus on deploying a scaled-down but genuinely valuable AI solution early on.
What's the benefit?
The MVAI allows the team to gather real-world data on how it performs, solicit actual user feedback, and learn incredibly quickly. This leads to faster iteration and ultimately a more effective final product that actually meets user needs. It's about getting that real-world feedback loop going as soon as possible.
That makes a lot of sense. Learn by doing and by seeing how users react.
Yeah, and that implies flexible sprints too.
How so?
Well, the rigid 2-week sprint cycle common in software development might not always work for AI. Tasks like large-scale data collection, complex feature engineering, or training massive models can be very time-consuming and unpredictable.
Right, you can't always train giant model into a neat 2-week box.
Exactly. So teams may need variable sprint lengths or different ways of planning to accommodate these complex, less predictable activities.
Okay, flexibility in process. And metrics.
Finally, adopt comprehensive metrics. Success in AI isn't just measured by technical model performance metrics like accuracy, precision, or recall. Those are important, but not enough.
What else do you need?
Teams must also track key business KPIs, key performance indicators, to ensure real business value is being delivered. Is it saving money, improving customer satisfaction, increasing revenue? And they should also track process metrics like development cycle times, maybe even team happiness, to ensure the process itself is sustainable.
Holistic measurement. It's also interesting to note the report mentions AI is being embedded within project management tools themselves now.
Yeah, AI helping manage AI projects. We're seeing tools that can automate tasks like suggesting project metadata, optimizing schedules based on past performance, predicting potential risks, summarizing progress reports, further streamlining the process.
The meta level of AI. Okay. And finally, under this implementation umbrella, let's talk explicitly about upholding ethical standards in AI deployment. We touched on principles in governance, but how does this translate into day-to-day practice? These aren't just high-level ideals, they require concrete practices throughout the entire AI lifecycle.
Precisely. Ethical principles without practical application are just good intentions. So first, mitigating bias. This has to be proactive and multifaceted. It's not a one-time check.
What does that involve?
It starts with curating diverse and representative training data sets, easier said than done. It involves conducting systematic bias assessments using specialized tools, implementing technical mitigation techniques like resampling data or adjusting algorithms, and crucially, assembling diverse development teams.
Why diverse teams specifically for bias?
Because people from different backgrounds and experiences are more likely to spot potential biases that might be missed by a more homogeneous group. They bring different perspectives to the table.
That makes total sense. Diverse teams spot diverse issues. Okay, what else?
Next, ensuring transparency and integrity. Organizations should be open and honest about where and how they are using AI. Documenting data sources and model workings is part of this. And importantly, presenting AI-generated content as purely human-created without disclosure. Well, it erodes trust and is fundamentally unethical.
Be upfront about the AI's role.
Yeah, professional and creative integrity demands it. Then, protecting intellectual property. This is huge, especially with GenAI's ability to generate novel content.
Yeah, huge legal questions here.
Absolutely. Strict policies must prohibit inputting copyrighted or proprietary material belonging to others into the AI for output generation, unless licensed. All AI-generated content should be vetted, perhaps using plagiarism detection tools. And a really critical point, organizations must not use AI outputs to train any other AI models without explicit permission from the original creators whose work might have influenced that output.
That's a major ethical and legal minefield if not managed properly. Feeding AI with AI output could create all sorts of feedback loops and IP issues.
Big time. Then there's fact-checking and human validation.
Given the hallucination risk.
Exactly. Acknowledge that generated outputs can be inaccurate, misleading, or just plain wrong. All AI-generated content, especially in high-stakes domains like healthcare, finance, legal, it must undergo rigorous human review before being used or published. Implementing human-in-the-loop processes is an essential safeguard against misinformation. It's about ensuring accuracy and accountability, not just speed.
The human expert still needs to sign off.
In many cases, absolutely. And finally, upholding data privacy. This is a fundamental ethical duty and a legal requirement.
Wow.
Implement robust data security measures. Adhere strictly to data minimization principles. Only collect and use the data that is strictly necessary for the task. And ensure full compliance with regulations like GDPR, General Data Protection Regulation, in Europe, and CCPA, California Consumer Privacy Act in California, and others globally. AI systems must be designed and operated from the ground up to respect individual privacy rights.
These guidelines, bias mitigation, transparency, IP protection, human validation, privacy, they truly provide an actionable framework for responsible AI deployment, not just abstract principles.
Exactly. It's about operationalizing ethics throughout the entire life cycle.
Okay, so we've thoroughly unpacked the foundational pillars of GenAI implementation, the crucial role of human capital and co-intelligence, the necessary technology stack, including RAG, and the essential governance, risk, and project management frameworks. It's a lot to take in.
It is a complex ecosystem.
But the blueprint drives home one more crucial point. GenAI adoption is not a one-size-fits-all endeavor. We hinted at this earlier. Its applications, the specific challenges, the resource requirements, they vary greatly across different industries.
That's right. A successful strategy must be tailored. You can't just copy-paste what works in finance into healthcare. The unique operational realities, the specific regulatory environments, the key value drivers, they're all different.
So context is king.
Absolutely. And the report provides detailed, actionable blueprints for several key industries. What's really useful is it includes a tiered model for resource allocation. Think small, medium, and large organizational sizes to help guide strategic planning and investment levels.
Okay, a tiered approach. That sounds practical. Let's delve into healthcare and life sciences as our primary example to really illustrate this tiered approach, because the potential impact there seems enormous.
It really is. In healthcare and life sciences, GenAI is poised to catalyze a genuine paradigm shift.
How so?
Well, it's addressing long-standing challenges in efficiency, discovery, and personalization. Think about automating those burdensome administrative tasks that contribute so much to physician burnout.
Like clinical documentation.
Exactly. Or fundamentally accelerating drug discovery, a process that traditionally takes over a decade and costs billions of dollars. GenAI is being used to identify potential drug targets, design novel molecules,
Shortening that timeline.
potentially dramatically.
Hmm.
It's also enhancing medical imaging analysis, helping radiologists spot anomalies earlier, potentially improving diagnostic accuracy. And it's unlocking personalized medicine, tailoring treatment plans based on an individual's unique genomic, lifestyle, and clinical data.
That's incredibly impactful stuff. Life-changing, potentially. But I imagine the challenges in this sector are enormous, given the stakes involved. Human health is on the line.
They are immense. You have extremely stringent data privacy regulations like HIPAA, Health Insurance Portability and Accountability Act, in the U.S., which demand an exceptionally high bar for security and governance.
Non-negotiable compliance.
Absolutely. Model accuracy and reliability are utterly non-negotiable when they inform medical decisions. Lives depend on it. And the risk of algorithmic bias inadvertently propagating or even amplifying existing health disparities is a grave ethical concern that requires constant vigilance.
Huge responsibilities, but the potential payoff must be significant too.
It is. Despite the challenges, the ROI potential is substantial. The report cites one study on a radiology AI platform that showed a remarkable 451% ROI over 5 years, driven by efficiency gains and, importantly, improved patient outcomes.
Wow, 451% ROI. That gets attention. Let's look at some key use cases in healthcare and then break down that resource tiering you mentioned.
Sure, for clinical operations, it's things like automating clinical notes during patient visits, summarizing complex patient histories from electronic health records, EHRs, and streamlining processes like prior authorizations for treatments or prescriptions.
Reducing the admin burden.
Exactly. In medical imaging, it's enhancing scan quality, automatically segmenting tumors or lesions, generating synthetic medical images for training AI models without using real patient data, and detecting anomalies.
Helping doctors see more faster.
Right. For drug discovery and development, it's accelerating the identification of potential drug targets, designing novel molecules de novo using generative models, predicting potential toxicity early, and optimizing the design of clinical trials.
Speeding up the path to new medicines.
That's the hope. And for personalized medicine, it's analyzing vast amounts of genomic and clinical data to suggest individualized treatment plans, and powering sophisticated virtual health assistants for patient support and monitoring.
Tailoring care to the individual. Okay, so how does the resource tiering look for healthcare? Let's start small.
Okay, for a small entity, picture a local clinic or a small research lab. Their scope would likely focus on administrative automation, maybe appointment scheduling bots, generating referral letters, or using AI to quickly summarize the latest medical literature for clinicians. Patient inquiries via simple chatbots could also fit here. The team. Probably not a dedicated AI team. Maybe 1-2 part-time tech-savvy resources, an office manager who's good with software, a research assistant using online tools. The technology stack would rely heavily on commercial SaaS, software-as-a-service tools. Things like AI-powered clinical documentation software, like Nuance DAX Copilot, maybe API access to secure, IPA-compliant LLMs for specific tasks, and off-the-shelf chatbot platforms. The estimated investment, likely less than $50,000 annually, mostly covering software license fees. And the governance focus. Strict IP adherence is paramount. Explicit patient consent for any AI use. And rigorous validation of any outputs coming from third-party tools before they influence care.
Okay, that's very accessible. Manageable scope, leveraging existing tools. What about a medium-sized organization, like a regional hospital or a mid-sized biotech company?
Right, moving up a level. For a medium organization, the scope expands. They might implement commercial AI tools for radiology image analysis support, develop custom models internally for things like predicting patient readmission risk, or use GenAI to help generate protocols for clinical trials. The team becomes more substantial. We're talking 5-15 full-time equivalents, FTEs. This involves building a dedicated internal AI team, including data scientists, ML engineers, perhaps an AI product manager to guide development, and crucially, clinical domain experts to ensure the solutions are clinically valid and safe. The technology stack gets more sophisticated. They'd likely use a robust cloud platform with healthcare-specific services, like AWS HealthLake or Google Cloud for healthcare. They might start fine-tuning foundation models on their own de-identified patient data. Seamless EHR integration becomes critical, and they need full MLOps platforms like Vertex AI or SageMaker to manage the model lifecycle. The estimated investment jumps significantly, probably in the range of $250,000 to $2 million annually, covering salaries for the team, cloud compute costs, platform licenses, and data infrastructure. And the governance focus matures. They'd need a formal AI ethics committee, establish model validation frameworks, perhaps aligning with standards like BS 30440.2023, and proactive processes for detecting and mitigating bias in patient data sets and model outputs.
Okay, a significant step up in complexity, team size, and investment. Now, what about a large player, a major pharmaceutical company or a national health system?
Here we're talking about massive scale and investment, often pushing the boundaries of the technology. Their scope is ambitious. Large-scale de novo drug discovery using GenAI to design entirely new molecules from scratch, developing proprietary foundation models trained on massive, unique genomic and clinical data sets they possess, maybe even building patient digital twins for simulating treatment outcomes before they're applied. The team is extensive, often 50-plus FTEs, potentially hundreds. This usually involves a multi-layered AI organization structure, like a central COE, combined with embedded AI squads in different research or clinical areas. Roles become highly specialized. AI research scientists, AI architects, MLOps specialists, bioinformaticians, computational biologists, regulatory affairs experts specializing in AI submissions. The team is extensive, often 50-plus FTEs, potentially hundreds. This usually involves a multi-layered AI organization structure, like a central COE combined with embedded AI squads in different research or clinical areas. Roles become highly specialized. The technology stack involves serious infrastructure, significant investment in on-premise or hybrid cloud GPU clusters for training these huge custom models, building custom LLMs and diffusion models from the ground up, extensive use of reinforcement learning for optimization tasks, and managing large-scale vector databases for complex molecular and genomic data. The team is extensive, often 50-plus FTEs, potentially hundreds. This usually involves a multi-layered AI structure, like a central COE, combined with embedded AI squads in different research or clinical areas. Roles become highly specialized. The estimated investment, easily over $10 million annually, sometimes much more. This reflects major R&D investment, the cost of highly specialized talent, and the massive compute infrastructure required. The team is extensive, often 50-plus FTEs, potentially hundreds. This usually involves a multi-layered AI organization structure, like a central COE, combined with embedded AI squads in different research or clinical areas. Roles become highly specialized, and the governance focus. These organizations are often leading the development of industry standards for AI in healthcare. They're actively engaging with regulators like the FDA or EMA. They need robust frameworks for managing high-impact risks, perhaps aligning with something like the OpenAI preparedness framework for frontier models. And they have to navigate complex global compliance and data sovereignty issues.
Wow, that's a world of difference from the small clinic. It really illustrates how resource needs scale dramatically with ambition and organizational size, especially in a sensitive field like healthcare. That tiered breakdown is really helpful.
Yeah, it provides a practical way to think about the required commitment at different levels.
While we won't go into that same level of tiering detail for every single industry covered in the blueprint, let's touch on a few other sectors to highlight their unique applications and challenges. How about financial services? You mentioned earlier it seems like a natural fit for GenAI due to its data-intensive nature.
It absolutely is. The financial services industry, with its incredibly high volume of knowledge work, structured data, and text analysis needs, is tailor-made for GenAI adoption.
What are some key areas?
Well, the technology is being rapidly adopted across the board, automating complex processes like compliance checks or report generation, enhancing risk management through more sophisticated fraud detection or credit risk analysis, and delivering hyper-personalized customer experiences. From chatbots, they can handle complex queries, to AI-driven investment advice.
So it spans from operations to customer interaction to core financial analysis.
Exactly. For a smaller entity, like an independent financial advisor, it might mean using intelligent chatbots to handle routine customer service inquiries, or using AI tools to summarize market research reports quickly.
Boosting individual productivity.
Right. But at the scale of a global investment bank or a major credit card company, we're seeing much more ambitious projects. The development of proprietary large-scale LLMs specifically trained on financial data like Bloomberg GPT, which made headlines.
Right, a domain-specific model.
And sophisticated algorithmic trading systems leveraging GenAI for prediction and execution, or enterprise-wide AI assistants helping wealth managers, like the system Morgan Stanley deployed.
What are the unique challenges in finance, though? It's highly regulated.
Extremely. That's a major one. There's an intense demand for modeled explainability, especially from regulators. You need to be able to explain why the AI made a particular decision, especially for things like loan applications or trading strategies.
The black box problem is a big issue here.
Huge. Data security is absolutely paramount, given the sensitivity of financial information. And there's a growing concern about the potential for AI-driven systemic risks, for example. If multiple trading algorithms start behaving in correlated ways, potentially causing market instability, sometimes called algorithmic collusion. So governance needs to be incredibly robust, focusing on explainable AI, XAI techniques for audits, rigorous bias detection in areas like lending models, and managing those systemic risks.
That focus on explainability and systemic risk is a significant differentiator. Okay, let's switch gears completely. How about manufacturing? How is Gen AI reshaping the physical world of making things?
It's fascinating because GenAI is driving a new kind of industrial revolution in manufacturing, influencing everything from design to production to maintenance.
How so? Give me some examples.
One big area is product design through generative design. AI algorithms can create novel, highly optimized component geometries based on performance constraints, often resulting in parts that are lighter, stronger, or use less material than human designers might conceive.
So AI is a design partner.
Exactly. It can explore thousands of possibilities humans wouldn't have time for. For a small machine shop, this could be relatively simple, like using built-in generative design tools within their existing computer-aided design CAD software for specific components they make.
Accessible tech.
But for a global automotive OEM or an aerospace giant, it means much more. Enterprise-wide factory digital twins, virtual replicas of entire production lines, where they can simulate changes or optimize processes using AI before implementing them physically. Using GenAI for designing complex systems like aircraft partitions or engine components, and even deploying autonomous humanoid robots like Tesla's Optimus for performing complex assembly tasks, trained or guided using AI.
Robots learning from AI. That's very sci-fi. What are the main challenges in manufacturing?
Often it's about the integration. Integrating these sophisticated AI systems into complex existing physical production lines safely and reliably. Ensuring worker safety when humans are collaborating with AI-monitored or AI-controlled equipment, and maintaining data integrity from sensors on the factory floor, all within the stringent requirements of quality management systems, QMS. Validating that an AI's suggestion for a design change or a process adjustment is actually safe and effective is critical.
Our final industry spotlight is media and entertainment. This is an area where Gen AI seems to be directly impacting the creative process itself, and it's been, well, profoundly disruptive already.
It certainly has. You could argue M&E is one of the sectors most immediately and fundamentally disrupted by Gen AI. It's rapidly integrating into practically every stage of the creative pipeline.
Like what?
Assisting with script writing, generating dialogue variations or plot ideas, creating concept art and storyboards incredibly quickly, composing original royalty-free music on demand, automating complex and time-consuming tasks in video editing and visual effects, VFX, like rotoscoping or object removal.
Making the creation process faster, cheaper.
Often, yes. And also enabling new creative possibilities. For a solo creator or a small marketing agency, this might involve using publicly available tools to draft blog posts, generate social media captions, create simple marketing images using text-to-image models like Midjourney or Dili 3, or get AI-generated music from services like Suno.ai.
Democratizing content creation tools.
To some extent. But for a major film studio or a global streaming platform like Netflix, the scale is vastly different. They're building proprietary large-scale recommendation engines trained on immense amounts of user-viewing data to personalize content discovery. They're using high-end AI for sophisticated VFX, like de-aging actors, creating realistic digital crowds, or even generating final shots used in films or shows. Lucasfilm's ILM is a big player here. They're also exploring AI for predicting box office success or optimizing marketing campaigns.
So efficiency, personalization, new creative tools. But there's a big but here, isn't there? The disruption is causing friction.
A huge but. This industry faces a unique dual disruption. On one hand, you have the potential for massive efficiency gains, cost reductions, and new avenues for creative exploration. On the other hand, it raises profound ethical and existential questions. Intellectual property rights for AI-generated content, authenticity, and the value of human creativity, the misuse potential of deepfakes and synthetic media, the future economic viability for human artists, writers, actors, musicians. This has led directly to high-profile tense negotiations with creative unions like SAG-AFTRA, Screen Actors Guild, and the WGA, Writers Guild of America, trying to establish rules and protections around AI use.
Right. The strikes last year were heavily focused on AI.
Exactly. So for large players, governance isn't just about internal policy. It's about negotiating industry-wide standards, setting ethical guidelines for synthetic actors or voices, combating malicious deepfakes, and managing large-scale content moderation involving AI. Managing the digital asset management DAM systems for all this AI-generated content, tracking provenance and rights, is also becoming a critical operational challenge. It's a really complex and evolving landscape.
We've covered a huge amount of ground. We've navigated this incredibly complex, yet, you have to admit, undeniably exciting landscape of enterprise Gen AI implementation. And I think it's become crystal clear throughout our discussion that success here isn't just about buying the latest AI model or hiring a few data scientists. It's really a holistic transformation of how an organization fundamentally operates.
Absolutely. That's the core message from Spear's blueprint and what we're seeing play out.
Yeah.
We've seen how human capital, particularly that really interesting concept of co-intelligence, where human creativity, critical thinking, judgment are powerfully augmented, not replaced by AI, is truly becoming the ultimate sustainable competitive advantage.
It's a profound shift in how we even conceive of work, isn't it?
It really is. And building those cross-functional teams, we talked about uniting technical, strategic, product, and ethical expertise that's no longer just a nice to have. It is a foundational requirement for any serious enterprise AI effort.
And while the technology itself is the enabler, not the end goal, architecting the right technology stack is absolutely critical for actually delivering on the promise for scalability, reliability, performance.
For sure. We unpack the strategic selection of foundation models and cloud platforms, the need to implement a robust MLOps lifecycle tailored for GenAI's unique challenges, and maybe most importantly, the critical role of vector databases and retrieval augmented generation, RAG, to ground AI in factual proprietary data and combat hallucinations.
That RG piece seems particularly key for enterprise value.
Definitely. Investing in these systems, especially in activating that dormant institutional knowledge through our architectures, is really an investment in creating a durable, defensible asset. It turns potentially decades of accumulated internal data reports, manuals, databases from a static archive into a dynamic, queryable resource that drives better decisions and unique capabilities.
Turning data liability into a strategic asset.
That's the potential.
And finally, this incredibly powerful technology must be wielded with incredible discipline and foresight. The implementation of robust governance, risk management, and adapted project management frameworks is absolutely essential for building trust, ensuring compliance, managing security, and navigating the profound ethical challenges that Gen AI inevitably presents.
You can't separate the power from the responsibility. That layered approach to governance we discussed, combining practical operational frameworks like NIST's AI RMS, ensuring compliance with evolving regulations like the EU AI Act, using security guides like SAIF, and maintaining a deep commitment to overarching ethical principles like those from the OECD, provides the necessary guardrails for responsible, sustainable innovation.
And as those industry spotlights made so clear, while the core principles of Gen AI implementation people, tech, governance are universal, their specific application must be tailored. It has to be adapted to the unique context, the regulations, the value drivers, the risk tolerance of each specific sector.
Exactly. From the high-stakes, highly regulated environment of healthcare and finance, to the dynamic, physically grounded world of manufacturing, to the fast-paced, creatively disruptive landscape of media and entertainment. Leaders have to make carefully considered, context-aware, tiered investments in people, platforms, and policies. One size definitely does not fit all.
So by embracing this holistic, strategic, and context-aware approach, organizations can move beyond just tinkering, beyond mere experimentation, and truly start to harness the full transformative power of generative AI, not merely to optimize existing processes around the edges, but potentially to redefine the very boundaries of what is possible in their industry.
That's the real promise, isn't it? Fundamental transformation.
There really is. And as GenAI continues its relentless march, embedding itself across every sector, transforming how we work, how we create, how we solve problems, it asks us, I think, to reconsider the very nature of intelligence itself and the future of collaboration. So here's a final thought for you to ponder. What does this profound shift toward co-intelligence, this partnership between human and machine mean for your role, your industry, or even just your personal learning journey as you navigate this new, rapidly emerging augmented reality?